Hello and welcome to Chapter 3. Now we're going to talk about conditional execution. Conditional execution is where we start sort of adding more intelligence. Sequential execution, you just type them in and Python does it. But sequential execution is where you can choose one of two paths, turn left or turn right or go straight. You can make choices. And this is an essential part of making computers seem intelligent. And so the key to this is the if statement. So the if statement is the reserved word that indicates that we're going to do something conditionally. And it's not that hard to read. So the if statement has a condition. It's really a question. This, unlike x equals 5, which changes potentially the value of x less than 10 is asking a question. It's asking, is x less than 10? And that returns a true or a false. At this point, because x is 5, x is indeed less than 10, and so it's true. These if statements end in a colon, and they start an indented block of text. It's kind of like an outline that basically says, if this is true, do this statement. Otherwise, skip the statement. So in this case, it comes in, x is less than 10, so it does the statement. Then it comes back, it says, if x is greater than 20, this one evaluates to false. And so that skips it. So that's why we see smaller printout and fini printout, and this line never executes. So that's why I call it conditional. Depending on this question that's being asked, the line inside the indented block will either execute or not execute. And so you can kind of look at this from sort of as if you were driving a car, right? You execute this statement, then it goes to the next one. Then it asks the question, is x less than 10? If the answer is yes, it turns this way and drives down here and runs this code, does that thing. And then it rejoins, and then it says, oh, is x less than 20? Well, since x is 5, the answer is no. And so that it skips that completely, and then it runs this, and then it's done. And so this code never runs, okay? And so when we say conditional, we say, yes, that one ran, but that one did not run. And so that's why we call it conditional, because it may or may not run. The other thing that's important about this is this indenting notion, that we start with an if, have this colon, and then we indent. The indenting can be a variable. We tend to indent by 4 spaces. That's the recommended pattern. And we'll see in a bit, the indents can be longer than one line. This is only a one-line indent where you have one line that's conditional, but we'll see in a second how we can do this with more than one line. So, good time to talk about the comparison operators. Again, the problem here has to do with the limitations of the keyboards in the 1950s and 1960s of computers when most of these languages were kind of designed. So less than is on keyboards, less than followed by an equal sign is less than or equal to. Double equal, this is probably the part that's the hardest. Double equal is a question mark. Remember, equals is an assignment statement. It has kind of a direction, x equals 1, right? X equals 1. That puts 1 in x. This, if you say, x equals 1, you're asking the question, is x equal to 1, and it doesn't harm x. So that's probably, it takes a while. If I was designing a language, I would say assign x into 1, and then this would be single equals, but sorry, I didn't design Python, so that's not the way it is. So double equals is the question mark version of equality. Greater than or equal to, and greater than, and then not equal is exclamation point. Another word for exclamation is bang. We say bang equal or not equal. And so the exclamation point is like not equal, or like emphasis. I don't know. That's how I remember it. Remember that none of these harm the data that they're looking at. They evaluate and then return us a true or a false. So here's an example of all these things kind of in action. For x equals 5, they're all going to be true. If x is equal to 5, remember that's the question mark. If x is greater than 4, yeah, and the answer is yes. Print greater than 4. If x greater than or equal to 5, that's also true, so this part runs. You can also, if it's only one line of stuff, you can sort of pull this line up to the end here. If x less than 6, print less than 6. If x less than or equal to 5, print less than or equal to 5. If x is not equal to 6, print 6. And so you see this pattern of indent, end of indent, indent, end of indent, indent, end of indent, indent, end of indent. So this is an important part of Python. Not a lot of languages make the indenting of lines a syntactically meaningful thing, but that is how Python works. And so if you don't indent it, it's not going to work the way that you expect it, especially if you're coming from a programming language like JavaScript or Java or C, where the actual spacing doesn't matter. In Python, the spacing does matter. And so this is an example of a longer block of text that's indented. And you can now see kind of how this indent works. You know, x is 5, we print before 5. If x equals 5, this is going to be true because it is, colon starts an indented block. Now, by maintaining the same indent, you make this all part of the conditionally executed block. So this is 3 lines of code that it runs this line, then sequentially runs this line, sequentially runs this line, and we indicate when it is that we want to get out of this block and then continue by de-indenting. Okay, so it runs, when it's true, it runs all of them. Then now it's running sequentially, and now it says, oh, if x is equal to 6, well, this one's going to be false. Then that skips all of these. None of these run. Skips all of the indented blocks. And so this indenting is a way to, in effect, make bigger blocks of conditional code or multi-line blocks of conditional code. So indentation is important in Python. It's more important in Python than literally almost any other programming language. We always use indentation in other programming languages to mentally keep track of blocks of text, but it's not where the programming language will complain if you get it wrong. So you have to sort of think, why did you increase the indent, which is like if, after an if or a for or a while statement, which we'll see in a bit. You maintain the indent, which means you stay the same, or then you de-indent, or you reduce the indent back, and that is the way to end a block, so you reduce it. Blank lines don't matter, and then comments by themselves on a line don't make any difference for indenting. And so as you're doing this indenting, it's really natural to hit the tab key on your computer and to move in. So you did if blah, 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 and then on the next line you hit tab. The problem is that Python can get very confused if you sometimes are using 4 spaces, space, and sometimes you use tab. And the danger is it can look right on your screen, but Python will still complain to you. And so if you're using a text editor that might be putting tabs into your document, you find where it turns them off. So a programmer editor, and we're not talking a word processor now, we're talking about a programmer editor like Notepad or Text Wrangler. These have a setting whether or not to turn tabs into spaces or not. So it either puts a tab in the file or puts spaces. And so this is a good time, if you're using one of these text editors, to make sure to turn tabs off or cause tabs to be expanded, so you don't end up with, in a few weeks or a few days, with Python errors that you just don't understand and that makes you grouchy. Here's the good news, and that is if you're using our recommended Atom text editor, it automatically, once you save the file with a .py extension, it automatically just uses, you hit the tab key and it moves in spaces. And so that is very nice, and it's just one of the many reasons that we recommend and like Atom to edit these files. So just understand that tab and spaces might look the same on your screen, but to Python they may or may not be equivalent, and you can end up with spurious errors that Python will give you if you get your tabs wrong. Okay? So here's just some of the screens. Depending on your tool that you're using, your editor that you're using, you might have to find it, but it's like auto expand tabs or replace tabs by spaces, etc. The idea is don't put tabs in your document. The best practice is to use spaces and don't put tabs in your document when you're writing Python programs. So you have to think about this, about the indenting and the de-indenting. When do you go in and when do you come back out? And so it's the way that we define blocks. So we have sequential code, which maintains the same indent. Now we see the if and we see the colon. That means we start an indent, and then to stay inside that block of code, you maintain the indent, and then to end that block of code, you de-indent. So you think of this as like, I'm de-indenting. I'm doing this on purpose. It's not like randomly. If this was in, then it would function differently. The fact that this print is out means it's not part of this if block. These two statements are part of the conditional code. The print really is the thing after the if, right? And so this is going to run no matter what. These two may or may not run. In this case, because it's true, they are going to run and come back out. So this is conditional code. This is sequential code. Sequential code. And if we continue down, we haven't talked about loops yet, but the for keyword is a loop, and this is telling it to run this thing 5 times, and it ends in a colon, and then you go in, and then you have some sequential code, then you have an if. This is called nested. That's a block within a block. So the if has another colon, so we go in even farther. And then we de-indent, to this level of this if, and then later we de-indent to the level of the for. So you kind of have to match these things up and decide how you're going to end your conditional code, or in the looping code, which we're going to learn in the next section, how that works. So what you want to do after a while, and it won't take you too long, but sort of train yourself to start thinking about the fact that these are blocks of code, that you can sort of draw these squares around the blocks of code. And I've drawn the square here. The if starts it. You can also kind of use the colon as your little mechanism, and then the de-indent stops it. And so this is the conditional code. And then you can see where the F starts, and then it's the line that lines back up with the for. That is the scope of the entire for loop. Same here with the if. The thing that lines up, that is the scope of that if block. So mentally, you have to realize that these de-indenting and indenting adds meaning to your program. I mean, they absolutely define which things are going to run as part of an if statement or regardless of the value in the if statement. So start seeing these. And in terms of nesting, you can see them inside one another. It's like the Russian dolls, where you've got a block of code. Within it, you got another block of code. And believe me, we'll go down, 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 out, 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 out. And so start seeing these indenting as blocks. Just start feeling that. Like I said, nested decisions. So there was a for loop with an if. We can also have a decision where there's an if within an if. And so in this case, x is 42. If x is greater than 1, that's true. So then we're going to print this. If x is less than 100, that's again true. So we're going to go in and run this. And then we've de-indented twice. And so this does line up with the if. So this functions as the end of both this block and the end of this block because it lines up out here. So if we look at it from a GPS perspective, it's true, x is greater than 1. We print that. We ask another question. That's a question. And it yes. And now we're continuing back down. So we kind of come out of the indent block. And as you're drawn, you kind of see this is indented once, and this one is indented twice, just the way I drew it. And the same is true here. This is indented once, and then getting too busy there. This one's indented once, this one's indented once, this one is indented twice, right? So start counting those indents and knowing how the de-indents work. So we have one-way decisions, and very commonly we have a two-way decision. We call this else. We want to basically do one thing or another. It's like a fork in the road. If something is true, in this case is x greater than 2, well, it's 4, so it is true. We do one thing, and if it's false, we do another thing. In this particular example, we don't do this one. We only do this one over here. But you got the idea that with one if test, we choose alternatively between one and the other of the choices. So this is how we write that in Python. We say, sequential code, question mark, colon. And then we have the true part. This is the part that executes if the question evaluates to true. And then we de-indent and use the keyword else. So else is a Python keyword. And you see another colon here. So we sort of de-indent, say else, and then re-indent. And then we have this part. And so that's how we capture the other half. And then, of course, it runs no matter what. So if we were to do this, if it's true, it runs this and then skips that. And if it were false, which it's not, it would skip this, run this, and then continue. The point is, if you use an if-else structure, one of these two things is going to run. And it's sort of the same as this. It comes in here. There's no scenario in which both run. It's going to run one, and by running one, it's not going to run the other one. That's how an if-then-else happens. So coming up next, we're going to talk about some more conditional execution patterns, a little more complex stuff, else if, etc. So welcome back. Now we're going to build up and talk about some slightly more complex conditional execution patterns that you can build up. So as you do the if-then-else, again, one of the things to do is to visualize the blocks. Start thinking of the blocks. And in this case, you think of the block as sort of starting at the if and then ending after the last indented line. But the if and the else kind of are a piece of one thing, and you can sort of think of this is the block, right? And one of the things about these blocks is they have one entrance and one exit. Not that that's a big deal, but it's a good way to think about how you mentally start drawing the blocks. You see one entrance and one exit, and there's some complexity. There's some logic that you're sort of building. And that's how these blocks work. So the next step up in complexity is a multi-way if, and that uses a keyword called elif, which is really a combination of else and if. So the way it works is, probably easier to do this on the GPS version of it, is it comes down here, forget what's in here, it asks yes or no. If it's yes, it runs this one and then it's all done. If it's no and then yes, it runs this one and it's all done. And if it's no, 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 it runs this one and it's done. A key thing is it's only going to do one of these three. It's not going to do two. It's only going to do one. And it checks these questions in order. And then this else is like a catch-all. So let's take a look at how this particular one works. It depends on the value of x. So what if x were 0? Well, if x were 0, it would come in, ask the question, is x less than 2? Yes, it is. So it would run this code, and it would finish down here. So it would come over here, true, run, and now skip all the way down. If you draw blocks, the box would be this box right here. It skips out of the box. Or if you draw the box over here, the box would be right here. Once you're done with this line of code, with this block of text right there, or block of code, you exit the block. You don't come back and look at this question. You have run, one thing is turned true, and you're done. If, on the other hand, x was 5, you would see a situation where it would come in. This would be false, and so it would skip. Then it comes to this next elif. This becomes true, so then it jumps in and does this code, runs out, and is done. Does not run that, does not run that, does run that. So comes in, no, it's not less than 2, it is less than 10, so we'll run that little block of code, and now we are all done completely. So no, no, but yes. Okay? And so that's how it works. These are done in sequence. They're not looked at sort of in parallel or all at the same time. If, on the other hand, x was 20, it would say false, skip, question mark, false, skip. Oh, else, then it's the else always gets triggered if it gets that far, and then it runs that one. So here we say, if it's less than 2, no, it's not. Is it less than 10? No, it's not. And if it's there, we just hit the else part, and we finish, and we continue on. So this part doesn't run, this part doesn't run, and that part runs. The rule is one of the three will run, and the other two will not. It only triggers once. Once it's triggered, then it's done with the whole if statement. And again, I think of this as the block. And you'll see in a sec, you can have one. Once one of these things hits true, it runs this and then exits the block completely. So there's other variations on this. You can, if you want, have no else. So there's no need to have an else. What we've done is we've simply de-indented this next line. There's no else here, but that's okay. It does mean that for some value of they might not either execute, right? Because there's no else. If there's else, then at least one will execute. But if there's no else, then it could be possible that 0 execute. In this case, x is 5. It's not going to do this one, but it is going to do that one because x is less than 10. But if x was, for example, 50, then that would be false, that would be false, and it would just go. And then neither of these two things would execute if x were 50. Okay? So it just means that you don't have to have an else if you don't want to. Further, you can have lots of elifs. If x is less than 2, do this. Elif, 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 elif. And remember, it checks them in order. First, second, third, fourth, fifth. So if x was 15, this would be false, this would be false, this would be true, so it would run this code, and then it would come down whatever's next down here. So again, only one of these is going to trigger. No, no, yes, no, no, no. I mean, 15 is indeed less than 40. If it came here, it would be true, but it doesn't matter because 1 has triggered, and so then it takes the entire block, and there's our entire block. So as soon as it executes 1, the next thing to do is escape or exit right out of the block. Okay? Got it? Okay, so here are a couple of puzzles. I'll give you a second to pause this. And the question is to look at some of these, depending on, for a particular value of x, you will have none of them execute. So which will never happen for some particular value of x. meaning you can pick any value for x you want, but there's some that you can't cause to execute. Okay? So I'll pause for a second, let you pause the video if you want, and then I'll come back and explain it to you. Okay, you had some time to pause. Hopefully you did pause or didn't pause, but it doesn't matter. You can still pause while I'm talking until I start drawing and telling you the answer. Okay, so in this one, if x is less than 2, do this, else if x greater than or equal to 2. The one that's never going to execute is this one right here. And that's because no matter what value of x, it is either less than equal to 2 or greater than or equal to 2. So for any value of x, no matter what you pick, it's either going to run this one or this one, but it's never going to run that one for any value of x. Okay? So that's a little tricky. I just happen to have constructed my logical questions in such a way that they covered all values of x, and so the else was kind of irrelevant. Now I wouldn't even draw this way. If I was going to draw this or write this code, I would probably just make this be an else, colon, and this not be there. But this was more of a puzzle than anything else. So in this next one, we have to remember that these things happen in order. So if x is less than 2, we're going to run this. If it's less than 20, we're going to run this. If it's less than 10, we're going to run this. But the problem is all values of x that are less than 10, for which this would become true, this is always true. So a value like 6, this becomes true. So that means that if it's something like 6, it's going to run this and come out and never ask this question, right? So that's the key. Even though this is true and this is true, for the 6, it never even gets here because this one triggered first. Okay? And so that's why this is the line of code that no matter what the value for x, will never run. Okay, so the last conditional code is what's called the try and except structure. And if you learn other programming languages, this sort of catching errors is a more advanced concept, but in Python we tend to have to use it earlier because there are things where if you don't use it, the code blows up. And the whole idea of a try except is that you have a bit of code that you know might fail. And so you kind of want to take out an insurance policy on it and say, hey, give this a try. If it works, great. If it doesn't, do this other thing. Don't blow up. Don't get a traceback. And so this is a way to eliminate or catch a traceback, something that would otherwise be a traceback. That's what this is for. So if you got some line of code and you know that this might blow up and have a traceback, then you use try except around it. Okay? So let's take a look at something. This is a sample we had from the previous code, and it comes down, it sticks hello Bob in, then it converts this to an integer, and we know that if these things aren't digit, this code blows up. And so it runs, and we get the traceback. The traceback happens because of this line right here. But the key thing about the traceback is that the traceback, as I told you before, it stops. And it stopped at line 2, which means this is the last line it executed. But it doesn't continue, which means this code is gone. I mean, it never gets there because it's like, I'm confused, I'm quitting, I have quit at line 2. Okay? I quit at line 2. So that code, it's as if it's not there. Now, sometimes that's fine with you. You just want to blow up and you want to see the message. You want to go look at line 2 and fix line 2, or maybe type the wrong stuff in. But sometimes you want to control for this. You want to say, you know what, I know what I want to do here, and I don't want to die, and I don't want to blow up. I want to continue. I want to put out an error message instead. And so the key is when this code blows up, it's something that you kind of take personally because, you are that set of instructions, and when a traceback happens inside the memory or CPU, that's you that's being vaporized. You've been tracebacked. And so we take it kind of personal. I mean, if you were to use software that I built, like the autograder for this class, and you started getting tracebacks, I'm like, hey, that's kind of a personal thing. I didn't do my job well. I didn't catch all the errors. I didn't think of everything. You could type something that would cause my code to blow up. And so I take that kind of personally. And so we have to be able to compensate for situations that we know might cause errors, especially those where the user can type something that can cause my program to blow up. That's really like I'm going to let you blow my program up. I am going to compensate. I'll tell you, sorry, that's bad data, but I don't want you to ever see a traceback because it's kind of shameful to see a traceback for a professional programmer. Okay, so here's how it works. It's a bit of stuff with some indentation and colons. It looks like a lot, but don't worry, you'll figure it out. So the idea is you have a line of code that you know is dangerous. So this conversion of an integer, let's just say this came from an input statement. In this case, we'll just make it be hello Bob. We know this is going to fail. And so this is the line in which we kind of want to take out insurance on. So instead of just putting this line in here like we did in the previous example, we just had it right there. Instead of taking that line there, we say, you know what, we're going to take and stick this in a try and except block. So we say the word try ends in a colon, which means it's an indented block of code. And then we put the dangerous line in there. And then we put except. And then the except is kind of like an else, an if then else. But what it really is code that Python will execute if something goes wrong. So this is either going to run and work and skip this, or if it goes bad, it's going to run, blow up, and then run this stuff and then continue on. But in no case will you get a traceback. Meaning if this line is going to generate a traceback, it actually just runs the except clause. So it's kind of like an if things work out, do this. If things don't work out, do this other thing. So in this case, when this runs, this is going to fail because that's hello Bob. And then it's going to come out here and set this to -1. So that's going to blow up. Set this to -1. That's going to print it out. So it says first equals -1. And so we didn't trace back. In the previous time we ran this, it traced back because we caught it. Now, the way the try except works is if everything is fine, it has no effect. So if the next thing we're going to convert is 123, the digits 1, 2, 3 in a string, we do a try, we try to convert it, and it works. And so we just keep on going. We don't run the except, so this code does not run because this code succeeded. There was no traceback that was going to be generated. There's a traceback generated up here. There was no traceback generated here. So it comes through, and the result is istir ends up with a integer 123. And so it's an insurance policy, or it says, I know this might blow up, and if it does, I'm giving you alternate text or alternate code to run. So the thing about the try except block, and you might be tempted to do this, and that is put your entire, if you're getting tired of tracebacks and blowing up, you might want to put your entire program in a try and except block. And you might say try blah, 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 and then except something bad happened. The problem is if your program is blowing up, you actually want to know about it. And the way the try and except block works is if it's in the middle of a try and except block and something goes wrong, like in this particular line, it doesn't come back and finish the try and except block. It actually exits to the except and then comes out. And to draw this in a diagram, so here we go, we start this thing, we're in the try block, we're doing print safe, doesn't hurt anything. We do this blows up with a traceback, and then that says go to the except block, run whatever's in the except block, and then continue on. What's not going to happen is it's not going to go back up and do this, or back up and try this one again. No, 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 no. Once it gets the except block, there is only one way out to the bottom. And so this line of code never executes. And so that's one of the things we try to do, where you don't put too much stuff in. You would put this print statement out here and this print statement out here, and you'd only put one line in the try except block if possible. Sometimes you put a few more lines in there, but you try to minimize. You know what line is dangerous. Print is not dangerous. And these two prints are not really dangerous. Don't put them in the block, because any line in the block, as soon as it hits a bad line with a traceback, it's out of the block, runs the except, and then continues on. So here is a more practical example where we're going to read a number from the user and print out either nice work or not a number. And so we'd take an input statement which stops and waits for us to type, and then we type 42, and then 42 goes into roster, and then we know that this int is dangerous, right? And this roster came from the user, whatever the user typed. And so we put it in the try block, and if it's 42, it converts, and it says ival is greater than 0, we print it out, so it says nice work. Now, we'll run this code again. Okay, we run it a second time, And now we enter something, it says 42, but it's like FORTY. And so 42 is what goes in here. We, as the programmer, had no control over what our crazy user was typing, right? You're starting to be a programmer, and crazy users do crazy things to your poor programs, even if they're only like 7 lines long. So we got 42 coming in here. We know this is going to blow up. This int is going to blow up with a traceback. But that's okay. We've compensated for that, and we told Python, hey, we know that might happen, and if you detect a traceback, jump straight into the except block, run this, set it to -1, and then continue on. So this is the de-indent of the try except block, and if it's greater than 0, we say nice work, but in this case it's not, and we say not a number, and so it comes out with not a number. What's not here is a traceback. There is no traceback in this. That's what we achieved, and it doesn't hurt. There's no, when it works, you don't need, the try except kind of does nothing, because the except code, when it works, is ignored. So it's like code you add in case something happens in an other line of code. Pretty cool, actually. So you have a couple exercises, and I've got some videos of those exercises. So in summary, what we talked about in this chapter is comparison operators, logical questions. Key is that these comparison operators don't change their arguments. You could say if x is less than 5, doesn't change the value for x. We have indentation and how important indentation is. One-way decisions with if, two-way decisions with if then else, nested decisions where you have an if inside of an if that moves on in, else if, and then try and except to catch errors that you want to catch. Okay? So thanks a lot.